Hello grade 12s and welcome to this exam practice video on or for the section on momentum and impulse. Now in this question we're not only going to apply what we know about momentum and impulse, but we will also make use of the principle of conservation of mechanical energy. This is the principle that said that the total mechanical energy in an isolated system is constant. We will also be making good use of our understanding of elastic collisions. But before we read the question and answer the questions, I'd like to remind you of the formulas that are available to you on your formula sheet. So, on your formula sheet under the heading force, you're going to see the formula for momentum, P equals mv. Please remember that momentum and velocity are both vector quantities, so direction is very, very important. We also have the impulse momentum theorem, which states that the impulse is equal to an object's change in momentum. Remember that we calculate impulse by saying net force multiplied by the change in time. Also, we can manipulate this formula so that we have Newton's second law in terms of momentum, and we do so by dividing both sides by time. So you'll notice that some of the formulas are not given on your formula sheet directly, but if you're familiar with your formula sheet, then you will know how to work around what is given to get what you need. We see on the formula sheet that change in momentum is equal to mv final minus mv initial. Now, because in the section on momentum and impulse, we often deal with elastic and inelastic collisions, you may sometimes need to look at the formulas under the section work, energy, and power, specifically for the formula that we use to calculate the kinetic energy of an object. And of course, if we are dealing with the principle of conservation of mechanical energy, then you're going to need the formula to calculate the gravitational potential energy of an object as well. So grade 12s, please familiarize yourselves with your formula sheet. Always have one with you while you study. And make sure that you also know the correct SI units of each of these values. Let's now move on and read through the question. This question says, two stationary steel balls, A and B, are suspended next to each other by massless inelastic strings as shown in diagram 1. Ball A of mass 0,2 kilograms is displaced through a vertical distance of 0,2 meters as shown in diagram 2. So far we have the mass of ball A, and we also know the height to which it is raised. Then they say, when ball A is released, it collides elastically. This is a very important word, and head on with ball B. Ignore the effect of air friction. Now, before we move on, let's check to see if there's anything else that we can label. Well, we also know that both of the balls are going to start off with an initial velocity of 0, so that's important to take note of. And I would like to remind you that an elastic collision is one where the kinetic energy is conserved. So the sum of the kinetic energies before the collision is going to be equal to the sum of the kinetic energies after the collision. These are good things to write down as you analyze what is given to you. Question 3.1 now says, what is meant by an elastic collision? Now I'm not going to write this down, but for 2 marks you will state, an elastic collision is a collision in which both total momentum and total kinetic energy are conserved. And for writing that down, you're going to obtain 2 marks. Now the question says, immediately after the collision, ball A moves horizontally backwards or to the left. Ball B acquires a kinetic energy, so now we're looking at ball B, of 0,12 joules and moves horizontally forward, that is to the right. Now we need to calculate a few values, a few physical quantities. Before we do so, since we are dealing with a direction to the right and to the left, let's choose one of these directions as forward. I'm going to choose towards the right as forward, as positive. Sorry for that. Yes, I'm going to choose towards the right as positive, and that means that towards the left is going to be the negative direction. I'm also going to label the kinetic energy. This is EK final of ball B. Okay, and now we can move on. Question 3.2 says, kinetic energy of ball A just before it collides, or we need to calculate the kinetic energy of ball A just before it collides with ball B. Use energy principles only. Now, when we look at a problem like this, there are two events that take place. Firstly, ball A, which is at a height of 0.2 meters above the ground, is going to be released from rest, and it's going to swing downwards. It's then going to reach this position where it will have acquired a certain velocity. We're going to call this the final velocity for this movement, this motion of ball A swinging downwards. That's the first event that takes place. After that happens, the two balls collide. A collision takes place, and that is the second thing that happens. We are interested in the kinetic energy of ball A just before it collides with ball B. So a collision has not yet taken place, and we've been given a tip, which is to use energy principles. Since this is an isolated system with no friction present, we know that we can make use of the principle of conservation of mechanical energy. So we write down our principle of conservation of mechanical energy as is displayed to your screen. We have this form and we have the one at the bottom, and we may be required to make use of both based on the information that is given to us. Very important is that this formula deals with only one object, and we are therefore just observing ball A as it swings from its maximum height to its lowest point. So in the beginning, or let's start off this way, what are we looking for? We're looking for the kinetic energy of ball A when it is at the bottom, right? As it swings down towards the bottom. Let's start off by substituting into the formula what we have at the top. We have half. Its mass is going to equal to 0.2. Ball A's velocity at the top, or speed, is 0. Plus its mass is 0.2. G is always a constant 9.8, and into this formula we only substitute the magnitude. H is 0.2 meters. This is going to be equal to, instead of using this form, I'm going to stick with EK because we're looking for the complete kinetic energy of ball A. Plus, at the bottom, the mass is still going to be 0.2. G is still a constant 9.8, but once the ball swings down to this position, its height is going to be 0. We can now manipulate this formula and plug values into our formula sheet, and in the end, we find out that the kinetic energy of ball A at the bottom is going to be equal to 0.392 joules. Of course, you can round this off to 0.39 joules. That is the kinetic energy of ball A. Now, I know in some cases, some of you would have instead found the velocity, and then you would have gone ahead and substituted it back into the formula for kinetic energy. That is perfectly fine. Your answer would be exactly the same. So over here, we're getting 1 mark for our formula, 1 mark for substituting, and of course 1 mark for the final answer, giving you a total of 3 marks. Now question 3.3 says, calculate the speed of ball A immediately after the collision. Now, I know often when we think of collisions, we immediately run to the principle of conservation of mechanical energy. But the problem that we have, not mechanical energy, of momentum, principle of conservation of linear momentum. But the problem that we have here is that we still don't know what the mass of ball B is. So we're going to have to make use of something else. And grade 12s, that is the fact that they told us that the two objects collide elastically. So we're going to be making use of this fact in order to find out the speed of ball A immediately after the collision. We start off by writing down a formula. So, unlike the principle of conservation of mechanical energy, this is the principle that we use in question 3.2, which applies only to one object. So, we're looking at one object, or if we have two objects that are joined together, we would observe that as one object, right? In question 3.3, we are looking at elastic collisions. An elastic collision takes place between two objects. So we are saying that the sum, this is for the sum of, we're saying that the sum of the kinetic energy for both of the objects, when we add them together, is going to equal to the sum of the kinetic energies of both of the objects after the collision. Here we are looking at two objects. And I often find that learners get very confused about this. Also, a lot of learners confuse this formula with the principle of conservation of linear momentum. So please be very, very careful, grade 12s. So we can now look to see what we have available to us. Well, firstly, in the previous question, we found the kinetic energy of ball A, right, as it hits ball B. After ball A swings down, it has a certain amount of kinetic energy. This is the kinetic energy with which ball A is going to collide with ball B. So for this second part of the motion, that is the initial kinetic energy. Don't get confused. We just calculated this to be 0.39 in the previous question over here. Then we have the kinetic energy of ball B. Kinetic energy is energy that an object possesses as a result of its motion. But we know that ball B is stationary. Therefore, ball B's initial kinetic energy is 0. So far, we've just been making use of this formula right at the top. We've not had to make use of the expanded version, and that is perfectly fine. Now remember, we are looking for the velocity of ball A, let's go up quickly, or the speed of ball A immediately after the collision. So now we're looking for this value. We're going to write down half. The mass of A is 0.2 and we have VA final squared. That is what we're looking for. In the end, we might not know the mass or the speed of ball B. But remember, right at the start, they told us that ball B acquires a kinetic energy of 0.12 joules. So we plug into the formula plus 0.12 joules. That is the kinetic energy with which this ball is going to move forward. Okay, so now we can plug all of this into our calculators, or we can manipulate the formula. Take the square root, of course, to get rid of the square on the V. Please do not forget your squares. And in the end, we find out that VA final, the final speed of ball A, is going to be equal to 1,64 meters per second. This is speed. Please remember that speed is a scalar quantity, so we do not need to provide our speed with any direction. Okay, so over here you're getting 1 mark for one of the formulas. You're getting a mark on the left, mark on the right, and 1 mark for your final answer, giving you a total of 4 marks. Now we can move on to the final question in this problem and in this video, which says we need to calculate the impulse of ball A during the collision, and this is for 5 marks. Now we know that to calculate impulse, this is question 3.4, we can say that the impulse is equal to the net force multiplied by the change in time. But we unfortunately don't know what net force is being applied, and we don't know for how long this net force is being applied. So we have a bit of a problem. But remember, we are very familiar with the impulse momentum theorem, which says that the impulse is also equal to an object's change in momentum. Remember that change in momentum is equal to mv final minus mv initial. And I'm writing down this formula exactly as it appears on the formula sheet. So we are performing this calculation for ball A. We know that ball A has a mass of 0.2. The final velocity we just calculated. But it is very important, or let me rather say this, the final speed we just calculated. But it is very important that we remember that when we calculate impulse, we're not using speed. Instead, we are using velocity. So the question is, in which direction is this object moving? In which direction is ball A moving after the collision? And this was told to us. They said, immediately after the collision, ball A moves horizontally backwards to the left. Remember that we chose towards the right or forward to be positive. Or if we didn't, then we're at least doing so now. So that means that when we plug the final velocity into this formula, we need to plug it in as negative 1,64. This is very, very, very important. Then we say minus, according to the formula. Again, the mass is 0,2. The initial velocity we need to calculate. Okay, so if in question 3.2 you perform that calculation, then you're very lucky. You've already done some of the work. But remember, in question 3.2 we calculated only the kinetic energy. But we know kinetic energy is equal to half mv squared. We know the mass and we know the kinetic energy of ball A immediately before the collision. So we plug into this formula the values 0,39. We have half, the mass is 0,2, and we're looking for V, which we're going to square. We're going to manipulate this formula and plug the values into our formula, into our calculators, and we find that the velocity is equal to 1,98 meters per second. Remember that this formula provides you with speed, right? But we were told that ball A starts off moving towards the right. So since it starts off moving towards the right, we're going to plug this into the calculation on the left as a positive 1,98. Now we plug all of this into our calculators and we find out that the impulse is equal to negative 0,72. Remember that impulse is measured in Newton seconds, but before we do that, we must interpret this direction. If forward or to the right is positive, then this negative means that the final answer is 0,72 Newton seconds, not newtons per second, but Newton seconds towards the left, or if you'd like, you can say backwards. Remember that impulse can also be measured in kilograms per meter per second. So if you left your final answer in kilograms per meter per second, then it would also be marked correct. So firstly, we had to calculate the speed. We then made use of the impulse momentum theorem. We plugged values into this formula and we found our final answer with the correct direction. And this gives us a total of 5 marks. Grade 12, this brings us to the end of this exam practice video. We will be taking a look at a few more exam papers or past paper questions for this section. So I hope that you join me in the next video. Thank you so much.